Friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Today we are going to discuss another important core subject for electrical engineers, that is power system. We will be discussing 11 questions. I have tried my level best to pick the questions from every possible area so that it matches with the level of questions which are going to be asked in your upcoming GATE 2023 examination. So everybody who is live with me, just quickly confirm your presence in the comment section. Hi Raghu, how are you? Welcome to the session. So let me just brief you what is the ideal duration and what is the agenda for today's session. The ideal duration for the session is going to be approximately 45 minutes to 1 hour. And we'll be discussing 11 important questions. So basically, not just questions, we are discussing about BARC exam website is not, it will open, don't worry. Okay, because of heavy traffic, maybe it is not getting open. So please have patience. Maybe tomorrow or after some time, it is going to be okay. Yes, Mr. Prakash, Ravi, how are you? Everybody, welcome to the session. So shall we start? Are you ready? Some of you may be joining me for the first time. So there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience. MTech from ITBHU in 2010, written a couple of books, and these are my areas of expertise. Before we start the session, some important information I want to convey so that you do not miss any of the important session. One of the legendary faculty, Sanjay Rathi sir from Electronics Engineering, he is going to conduct a workshop on perfect strategy to ace GATE 2024. So if you have a colleague, if you have a junior, or you yourself interested in GATE 2024, then you must join this workshop. It is going to be conducted tomorrow, that is 31st of January, 7:30 p.m. in the evening. But to attend this workshop, you have to get yourself registered first. That is required. Raghu, I was going through the notification. I have taken the session also, but I think dates I could not find. So maybe within the same video comment section, I will be updating the dates also. Okay. Just give me some time. Now it's about the All India Open Mega Mock Test for GATE 2023, which we were conducting from 24th of January to 30th of January, and today is the last day. To attend these mega mock tests, you have to get yourself registered on the BYJU'S Exam Prep app. Now, one of the most awaited session for all the engineers, it is going to be common for all the branches. You please share this session, the link for this session among your friends. I will just try to share it with you in the comment section if possible. And this session, I will be discussing complete verbal ability part, that is vocabulary, because vocabulary is one area where everybody finds a little difficulty how to cope up with that. So I will be trying my level best so that I can give you complete coverage of vocabulary in just one session, and I hope it is going to be quite helpful for you. So please spread this link to your friends and colleagues, and do set the alarm and like the session. Just a moment. After the session, you can join. It is going to be conducted tomorrow, 12 p.m. in the afternoon. And it's not going to be like a session which is going to build your English language, frankly speaking. It is just so that you be prepared for upcoming GATE 2023 examination, because you also can understand that within just one session, I cannot do some magic tricks so that you remember all the vocabulary words which may be asked in your examination, but I will try my level best so that some important, most frequently asked words at least we cover, and that will give you a lot of confidence at least. Anyways, one of the most awaited sessions throughout the year, GATE 2023 live exam analysis, BYJU'S Exam Prep is bringing for all the branches. For electrical, electronics and computer science, it is going to be conducted on 4th and 5th of February, 1 p.m. and 6 p.m. in the evening. So subscribe to BYJU'S exam prep so that you remain updated for all these important sessions. Let us see the first question. The first question I have taken from the very basic, that is the calculation of inductance. So it is a single phase line. This is the forward conductor. This is the return conductor. Both the conductors are, you can see, it is going to be a bundled conductors, you can see, and A1, A2, A3 are going to be the subconductors in case of you can say forward conductor, and B1 and B2 are going to be the subconductors for the case of return conductor. So let us try to find how you are going to find the inductance. So we are saying the total inductance of the line, that is the loop inductance or total inductance, it is going to be a summation of forward path plus return path inductance. It means we have to calculate the forward path inductance separately and return path inductance separately. And because it is unsymmetrical, you can see the A conductor and B conductor are different. So first you will be finding the inductance for A conductor. It will be 0.2 ln GMD for A conductor divided by GMR for A conductor millihenry per kilometer. What is going to be GMD for A conductor? GMD for A conductor is going to be GMD for A1, GMD for A2, GMD for A3. How many GMDs? 3. How many GMD you want? 1. What is the power? 1 by 3. Nothing to remember. Just use your logic, use your common sense. And if you have not attended the GMD and GMR calculation sessions, then you please attend that. Now, if you want to find what is GMD A1, just see here. GMD A1 is going to be the distance between A1 and B1 and A1 and B2. So it is going to be distance between A1 and B1 and distance between A1 and B2. What is the power? Two distances. GMD is another. GMD is again a distance, so power is 1 by 2. Can you tell me what is the distance A1 and B1? A1 and B1 distance is 9 meters. So it is 9. What is the distance A1 and B2? A1 and B2 is going to be this distance. Can you calculate this distance? This distance, I think it is going to be under root of 9 square plus 6 square. Just find it. I think you must be getting it somewhere around 10.81. Please confirm this. 10.81 meters. Are you getting this? 10.81 meters something, and power is 1 by 2. Similarly, you can write the GMD for A2. What is going to be GMD for A2? GMD for A2 is going to be the distance between A2 and B1 and A2 and B2. Distance between A2 and B1 and distance between A2 and B2, power 1 by 2. Again, what is the distance between A2 and B1? A2 and B1 is going to be the same distance that you have just found. Yes, Raghu, please wait. 10.81 you are getting, na? Perfect. So A2 B1 is going to be same as A1 B2, 10.81. So just put it 10.81. And what is A2 B2? A2 B2 is again 9 meters. So this is power 1 by 2. What you are getting as GMD A1 and GMD A2, it is going to be same. So GMD A1, Raghu is getting 9.86. Others, please confirm. 9.86 meters. 9.86 meters. Now let us find GMD A3. GMD A3 is going to be distance between A3 and B1 and distance between A3 and B2, power 1 by 2. What is the distance between A3 and B1? A3 and B1 is going to be this distance. Can you calculate this distance? It is 6 plus 6, 12. So under root 12 square plus 9 square. Just calculate this. So you will be getting 12 square plus 9 square under root A3B1. And what is A3B2? A3B2 is going to be same distance that you have just found. This is also going to be 10.81. If you see the distances, if you see the symmetry, it is going to be 15. Okay. So this is going to be 15 into 10.81 power 1 by 2. Just calculate this value. So now you finally have the GMD for a conductor. It is 9.86, 9.86, and what you are getting for GMD A3? 12.73. Perfect. 12.73. What is the power? 1, 2, 3. So power is 1 by 3. Just calculate this, you will get GMD of A. Now you have to calculate GMR of A. GMR of A is again going to be GMR of A1, GMR of A2, GMR of A3. What is the power? 3 GMRs. How many GMR you want? 1. What should be the power? 1 by 3. What is GMR A1? GMR A1 is going to be the effective radius of A1. That is going to be 0.7788 R. It should be R1 for A conductor, R2 for B conductor. So R1 is 2.5 mm. So this is R1 multiplied by distance between effective radius, or you can say 0.7788 R1 for A1, effective radius of A1, multiplied by distance between A1 and A2 and A1 and A3. Because GMR we are finding within the same conductor, within the same phase or group of conductors. So it is going to be effective radius for A1 multiplied by distance between A1 and A2 multiplied by distance between A1 and A3. How many distances? 1, 2, 3. What is the power? 1 by 3. Can you calculate this? GMR for A2. Again, the effective radius of A2 0.7788 R1 multiplied by distance between A2 and A1 and distance between A2 and A3, power 1 by 3. Just calculate this. Similarly, you can find the GMR for A3 also 0.7788 R1 for A3 subconductor and distance between A3 and A1, A3 and A2, power 1 by 3. Just put the values. What you are getting as GMD A? Anybody has calculated? Raghu has calculated. R1 is how much? R1 is 2.5 millimeters. R1 is 2.5 millimeters. And R2 is 5 millimeters. Okay. So GMD A, Raghu is getting 10.73. Others also please confirm. 10.73 meters. That is GMD for A. What is GMR A1? Just put the values. It is going to be 0.7788. What is R1? 2.5. Now please remember it is millimeter. So you have to take care of the units also. It is millimeter. So this is going to be 10 to the power minus 3 multiplied by distance between A1, A2 and A1, A3. Distance between A1, A2 and A1, A3. So it is going to be 6 into 12. 6 into 12. Yes or no? 6 into 12. How many distances? 1, 2, 3. Power 1 by 3. Calculate it. Similarly for GMR A2, it is going to be 0.7788. R is 2.5, 10 to the power minus 3 multiplied by distance between A2A1 and A2A3. A2A1 and A2A3 is going to be 6 into 6. So this is 6 into 6 power 1 by 3. Just calculate these two values. GMR A3, it is going to be 0.7788. R1 is 2.5, 10 to the power minus 3 because millimeter distance between A3A1 and A3A2. A3, A1 is 12, A3, A2 is 6. So 12 and 6 multiply. Okay, I have missed one page, no problem. Let me just remove it. So we were calculating GMR A3 as 0.7788 R1 D A3 A1 into D A3 A2 power 1 by 3. So it is 0.7788, radius is 2.5, 10 to the power minus 3, distance between A3 A1 is 12, A3 A2 is 6, power 1 by 3. You must have calculated now. GMR A1, GMR A3 is going to be same, obviously. On the symmetry, you can save your time. So GMR A1 and GMR A3, how much you have calculated, tell me, and then GMR A2. And finally, tell me GMR A. GMR A1 and A3, Raghu and Ravi, they are getting 0.519. A1 and A3, 0.519 meters. Is it clear? Have you taken care of the units? Yes. GMR A2, Ravi is getting 0.412. Please confirm this value, 0.412. What is GMR A? Multiply A1, A2, A3, GMR, take the cube root. Again, one page left, no problem. Just put GMR A1, A2, A3 and take the cube root. You have to tell me the values. Final GMR you have to tell me. How much practice you can do in terms of calculation, that is going to be much better for you. For next 10 days, even if you do not study anything, do one thing. Take a small 10 or 20 pages book for Sudoku. Even if you are not able to solve it 100%, every day you solve one puzzle of Sudoku. You understand Sudoku? Newspaper also you get. Because how effectively your brain is going to function in the examination, that will decide. Ravi is saying GMR A as 0.48. Others, please also confirm. It's not just simply watching the session. You will not be able to do it in the real examination if you don't practice it. When you are in the waters, you have to swim. You have no other options. When you are outside this ocean, then you can just sit and watch. But when you are inside the ocean, when you are in the waters, you have to swim, no other option. Raghu is also getting 0.48, so I am assuming it is correct, 0.48. Now you can put the values. Now you can put the values and you can find LA, it is 0.2, LN. What is GMD A? GMD A. GMD A is 10.73. 10.73 upon GMR. How much is GMR A? 0.48 meters. 0.48 meters. This is millihenry per kilometer. Please calculate this. Please calculate this. Okay. Now similarly you can find. Okay, let me just do it. Okay, otherwise you will not do it. I know. You will never ever do it. Just tell me how much you have calculated the inductance for a conductor. Now I will be writing the inductance for B conductor. It is 0.2 ln GMDB upon GMRB. It is millihenry per kilometer. How you are writing GMDB? Now in B conductor you have two subconductors B1 and B2. B1 and B2. So it is going to be with respect to A1, A2, A3. So it is going to be GMDB is going to be GMD B1, GMD B2. How many GMDs? 2. How many you want? 1. Power 1 by 2. What is GMD B1? GMD B1 is distance between B1 and A1, distance between B1 and A2, distance between B1 and A3. How many distance? 3. Power 1 by 3. What is the distance between B1 and A1? B1 A1 is 9. B1 A2. What is the distance? 10.81. Distance between B1 and A3, it is 15. So 9, 10.81, 15. So it is 9, 10.81, it is 15. Power 1 by 3. Just calculate it. GMD B2. GMD B2. Distance between B2A1, B2A2, B2A3, power 1 by 3. What is the distance between B2 and other conductors in A? 10.71, 9 and 10.71. Sorry, 10.81. So this is 10.81. 10.81 into 9, power 1 by 3. Just calculate it. Raghu is getting LA as 0.62. LA as 0.62 millihenry per kilometer. Everybody just confirm this value. So what you are getting in terms of GMD B1, have you calculated? 9 into 10.81 into 15, take the cube root. GMD B1 is 11.34. 11.34, perfect, 11.34 meters. And GMD B2 you are getting is perfect. Sudarshan, Krishna, Raghu. What is GMD B2? 10.81, 10.819. Now, if you are getting a question on GMD, GMR and you are doing a mistake, then it's very difficult. GMD B2, Raghu is saying 10.16, perfect. Others please confirm 10.16. Ravi is also saying 10.16. 10.16. 10.16 meters. Once you have GMD B1, B2, just put it here. You will be getting the GMD B now. What is GMD B now? $11.34. GMD B 11.34. 10.16 power 1 by 2. Just calculate it faster. Hi Ashok, good evening. Welcome to the session. So GMD B finally you are getting, Ravi is getting 10.739. 10.739. What is going to be GMR for B? Now it is symmetrical. GMR for B1, GMR for B2. How many GMR? 2. How many you want? 1. Power 1 by 2. But by the nature of symmetry, you can understand from this diagram, by the nature of symmetry, you can understand that GMR of B1 and B2 is going to be same. Yes or no? Radius is same, R2 is 5 millimeters for both the conductors, and the distance between B1 and B2 is same as between B2 and B1. So it is going to be symmetrical. So you can write Yes, you can write because GMR B1 is equal to GMR B2. So directly you can find GMR B if you find GMR B1. What is GMR B1? Effective radius for B1 multiplied by distance between B1 and B2. Power is 1 by 2. Now you write it here. 0.7788, R2 radius is 5 millimeters, 10 to the power minus 3 because it is millimeter. And what is d B1 B2? Distance between B1 B2 is simply 6. B1 B2 is 6. Yes or no? Calculate. You will get GMR for B. Now Ravi is quite fast now. He is saying GMR for B is 0.153. 0.153 meters. Now you put the values and you can write the inductance for B conductor, that is LB 0.2 ln GMDB 10.739 divided by GMR B 0.153. This is millihenry per kilometer. Let's solve this. So LB, Ravi is getting 0.851. Please others check. 0.851 millihenry per kilometer. So can you tell me the total or loop inductance forward and return path? It is going to be LA plus LB. What was LA? What was LA? 0.62. 0.62 plus it is 0.851. Just add this millihenry per kilometer. So it is going to be 1, 5, 2, 7, 8, 6, 14 के 4 हासिल लगे 1, 1.471 millihenry per kilometer. If your calculations are correct, this is going to be the perfect answer. Now just to give you some idea, okay, I hope you must be aware with this. This is for a single phase 2 wire line. If it is given a 3-phase system, no need to worry. Okay, no need to worry. You just find directly the inductance per phase by finding the GMD system and GMR system. We have already discussed it. Anyways, let us come to the next question. Induced EMF of a neutral wire. The neutral wire is mentioned here and there are 3 phases A, B and C operating at 50 Hertz. The distances between the conductors are given. It is the horizontal spacing and you have to find the EMF induced in the neutral conductor, whereas the current in IA, IB and IC, that is ABC phases, are unbalanced because they are not same. Okay, because they are not same. So you can use the concept of radio interference here. What is the concept of radio interference? In general, I am saying, listen very carefully, in general, I am saying, I am just giving you the concept. The EMF induced you can write as M di by dt. Yes or no? Can you write M like you write L di by dt, because here it is a mutual flux linkage. So can you write M di by dt? Yes. Now if I am interested, this is the instantaneous value. Now I am interested in the RMS value. This is the RMS value. This is the instantaneous value. So RMS value, it is going to be what? M, RMS value of current multiplied by omega. Hello? Yes or no? Remember, say yes or no. Yes. Now what is M into I? What is M into I? How you define M? M is mutual flux linkage divided by the current. Yes or no? So what is M into I? This is nothing but the flux. Write the flux multiply by omega. You will get the RMS value of the EMF induced. Yes or no? The story is over. This year you may get a question on this. When I say this, it actually comes. After the exam, I will show you this snapshot. You have the currents in complex form. So I'm going to write now the RMS value of the EMF induced. So first I am writing because of the current in A conductor plus, then because of the current in B conductor, then because of current in C conductor. So this is going to be total flux linkage multiplied by omega. What is the total flux linkage? It is the flux linkage because of A current, so it is 0.2 IA ln 1 upon distance between neutral wire and A. So it is 2 plus 2 plus 2, that is 6. So it is 1 by 6 plus 0.2 IB ln. What is the distance between B conductor and the neutral wire? This is 2 plus 2, 4. So it becomes 1 by 4. Plus 0.2 IC ln, distance between C conductor and neutral wire. So it is 1 by 2. Are you getting this or not? So can you solve this? Tell me yes or no. 0.2 ln 1 by 6. This is going to be the factor. And what is IA? 20 plus J20. 20 plus J20 plus similarly 0.2 ln 1 by 4. What is IB? 15 plus J25. 15 plus J25 plus 0.2 ln 1 by 2 factor. What is IC? 30 minus J10. 30 minus J10. Can you solve this or not? Now, if you can solve this, whatever total flux you are getting multiplied omega. What is omega? Omega is 2 pi f, where f is the frequency given 50 hertz. Is it clear, everybody? So this is I am giving you as part of your homework, and just put it the answer to this question in the comment section. I will confirm that. Okay, you solve it in the comment section of this video. I will confirm this answer, but you have to do it. Calculation, how much you can do till your examination, that is going to be the best thing. Read good stuff. Don't see a lot of mobile. Every day before you go to sleep, don't watch mobile. This is my humble request. Whatever you are doing 360 days, that is different thing. For next 5 days, don't watch mobile before you go to sleep. Okay? Because if you keep your brain engaged all the time, even during the night time also watching late night mobiles and useless videos, your wiring or the network or the reaffirmation of the memory in the brain, it gets very slow. So your brain need nourishment. As you need nourishment, your brain also need nourishment. So start eating a little bit of vitamin C. Right now there is a good quality oranges are coming in the market. Okay, 1 or 2 oranges a day you can eat. That will keep you fresh, antioxidants, keep your body healthy. This is very crucial period for you. And please, for next 5 days, do not watch useless stuff in the mobile. You can watch it after the examination. Okay. See the next question. Now it is a previous year question, but it's something, sometimes GATE is asking this type of tricky questions. It's not difficult, it's just tricky. You have to use a little bit of your brain spontaneously. Ravi is asking, sir, how we are writing 1 by 6. This is how we are writing the mutual inductance here. This is how the mutual inductance formula is. The mutual inductance formula is 0.2 ln 1 upon d, the distance between the conductors between which you want to find the mutual inductance. Because you are writing flux, and flux is M multiplied by I, so we are writing 0.2 IA, distance between A and N. So 1 by D. I hope, let me just write it. Wait. I hope you are not clear with the inductance formula. What is the inductance formula? Suppose for a conductor I am writing in general, okay. It is mu naught mu r conductor material divided by 8 pi plus mu naught mu r, this is medium, divided by 2 pi ln. It is 1 upon r minus mu naught mu r medium divided by 2 pi ln 1 upon d. So this formula you have to remember. This represents L self due to internal flux linkage. This represents L self due to external flux linkage, and this represents L mutual due to external flux linkage. Is it clear, everybody? And you have to be very careful. The general expression that you are remembering 0.2 ln GMD upon GMR millihenry plus millihenry per kilometer, that is only applicable when it is an aluminum conductor. If the conductor material is changed to copper or something else, then you have to be very careful, because here you have to put the relative permeability for the conductor, whereas here you have to put for the medium. Now generally for overhead transmission lines, the medium is going to be air. So for medium you can take as 1. For conductor material you have to be very careful. If it is aluminum, then only you can use 1, otherwise it is going to be given in the question and you have to use accordingly. See the next question. Okay, Mr. Ravi. Now it's a distribution question. It is saying a single line diagram of a 4-bus single source distribution system is shown below. Branches E1, E2, E3, E4 have equal impedances. The load current values indicated in the figure are in per unit. So this is one generator and there are 4 sections, E1, E2, E3, E4, and these are the loads connected in terms of the current. The resistances are same, equal impedances, you can say. Distribution company's policy requires radial system operation with minimum loss. This is radial or ring mains. What is the difference between radial and ring mains? Radial means no closed loops are present, and ring mains means at least one closed loop is present. So at least one closed loop is present. So right now this is ring mains, but now he wants to make it radial. So he is saying with minimum losses, he wants to know this can be achieved by opening which of the branch of this loop. So basically you have to take 4 cases. You remove first E1, then E2, then E3 and the E4, and then you calculate in which case you are getting the least losses. That is going to be the best choice for you. So first you open E1. Opening E1. If you open E1, then it becomes, this is the generator, E1 you have opened, okay. This is E2, this is E3, this is E4, this is E3, this is E4. And what are the current values? This is 5, this is 5. This is 2 and this is 1. So can you tell me current in different sections? Yes or no? See, this is 2. See, this is 2 and this is 1. So 1 plus 2 is going to be 3. Yes or no? 1 here, 2 here. So 3 must be coming from here. Now 3 plus 5, 8 must be coming from here. Yes or no? And what is the current in this section? 1. Now the loss is directly proportional to square of the current, because resistance is going to be same for all the branches. So if you want to find the losses, it is going to be 8 square plus here current is 3, so 3 square plus it is 1 square, so it becomes how much? 64 plus 9 plus 1, so it becomes 74. Take the second case. Open E2. Open E2, so it becomes something like this. This is E1, this is E3, this is E4. What are the currents? 1, 2, 5. This is 1, this is 2, this is 5. Now 5 is coming here, so 5 must be coming here. 5 plus 2, 7. So here it is 7. 7 plus 1, 8. So now the loss is going to be directly proportional to 8 square plus 7 square plus 5 square. So it is how much? 64, 49, 25. So 9 4 13, 5 18 के 8 हासिल लगे 1, 6 1 7 4 11 2 13, 138. Is it clear? Now opening E3. Opening E3. If you open E3, so this is E1, this is E2, E3 you have opened, and this is E4. What are the loads connected? This is 1, 2, 5. This is 1, 2, 5. E3 you have opened. So 1 must be coming from here. Now 2 is coming here, so 2 must be coming here, and 2 plus 5, 7 must be coming from here. So what is the loss? Is directly proportional to 7 square. This is 2 square plus this is 1 square. So it becomes 49 plus 4 plus 5. So 9 4 13, 5 18 के 8 हासिल लगे 1, 4 1 5, 58. Now opening E4. Opening E4 generator. This is E1, this is E2, this is E3. This is 1, 2, 5. Okay. So what are the currents now in different sections? Now here 2, so it should be 2 here. Now 2 plus 1, 3 should be here, and this is 5. So what are the losses? Directly proportional to 5 square, 3 square plus 2 square. So it is 25 plus 9 plus 4. So 9 5 14, 4 18 के 8 हासिल लगे 1, 2 1 3, 38. Yes, Raghu. In third case, it's plus 1, not plus 5. Okay. I was checking whether you are attentive or not. It should be 1, na? Okay. It is 1. So 9 4 13 1 14. So it becomes 54. Still you are getting the same answer. Still you are getting the same answer. So what you are going to open? If you open E4, open E4, this is the fourth case. The losses are directly proportional, amounts to 38. नहीं ऐसा कुछ नहीं खेला मैंने. तुम लोग यंग हो, अब तो हमारी उम्र हो चली दोस्त, लेकिन जो खेल तुम खेल रहे हो हमने भी कभी खेले थे, बड़े खूब खेले थे. Anyways. No, it's okay, it's okay. Never say sorry. So are you getting the idea how you have to do it? So what is the correct answer for you? D option. E4 you have to open. Is it clear, everybody? See the next question. Now this year I feel that one question you will be getting from the Jacobian matrix, okay? Because number of years almost they have not asked the question on this. So maybe theoretical question they will be asking, or they will be asking a question directly based on the size of the Jacobian matrix. Now see what he is saying. There are 100 buses in the system. So total buses are 100. Direct question I have taken, out of which there are 10 generator buses. So generator buses are 10 plus there are 5 reactive power adjustment buses, that is voltage control buses. So total there are 15 generator buses. Reactive power adjustment buses or voltage control bus is just a generator bus having some voltage control capability with an added layer. Now there will be one bus as a slack bus. So how many number of PV buses you will be getting? 15 minus 1, that is 14. What is the number of PQ buses? Total buses minus total generator buses. So it becomes PQ buses. Now what is going to be L? L is going to be number of P specified. P specified means those buses where P is a known quantity. So where P is going to be a known quantity? P is going to be a known quantity on PV bus also and PQ bus also. So add it, 85 plus 14. So it becomes 85 plus 14. So it becomes 95, 8, 9. What is M? M is number of Q is specified. It means those buses where Q is known. Reactive power is known. Now reactive power is only known on PQ buses, not the PV buses. So that is 85. So directly M you are getting as 85. And what is the size of the Jacobian matrix? If you remember, this is delta P, delta Q. This is this is the relation you are getting for the NR method. So if you see the sizes of the sub matrices, this is L, this is M, this is L, this is M. So what is the size of this Jacobian matrix? This is the Jacobian matrix and its size is given as L plus M cross L plus M. So add L plus M, L plus M. So 9 5 14 के 4 हासिल लगे 1 9 1 10 8 18. So 184. Yes, perfect. So C is the correct option. See the next question. It belongs to the steady state stability. The real power transferred is given in the question, that is the 70 megawatt. A 15 kilovolt synchronous generator is connected to an 11 kilovolt infinite bus through a transmission line as shown in the figure. Find the displacement angle for the current operating point. So these type of questions very easy you can approach. Just you need to find the total X equivalent. Similar question you may get in the gate examination. Only thing you have to do is find the X equivalent between the generator and the infinite bus or the load. So you can write the real power transfer to the infinite bus is magnitude E, magnitude V divided by X, total X equivalent, and this is sin del. Now P value is already mentioned as 70 megawatt. So this is going to be 70 10 to the power 6. What is E magnitude? It is given as 15 kilovolt. So this is 15 kilovolt. What is voltage magnitude for infinite bus? This is 11 kilovolt. 11 kilovolt divided by, what is X equivalent? X equivalent is going to be X of generator plus X of transmission line. So X equivalent becomes X of generator plus X of transmission line. This is 1.2 plus 0.8, which comes out to be 2 ohms. So just put the values, and this is sine del. So find del, approximately 68 point something you must be getting. Okay, 58, sorry. 58 point something you must be getting. Please cross check the value. 58.4 or something. Is it clear, everybody? See the next question. Now it's a statement based question. There are two statements. You have to identify the correctness of these two statements, and you have to check whether the second statement gives the correct reasoning for statement 1 or not. Let us see statement number 1. Statement number 1 says, for a given plug setting multiplier, if the time multiplier setting is increased, then the relay operating time is increased. How you are defining the time multiplier setting? It is defined as operating time, actual operating time of the relay, divided by operating time of the relay for time multiplier setting is equal to 1. If you plot the variation between the time of operation of the relay, and this is the plug setting multiplier. Now plug setting multiplier gives you which information? Plug setting multiplier gives you the severity of the fault, how dangerous your fault is. So more and more fault current means what? More and more fault current means what? Less and less time of operation for the relay. So it is a rectangular hyperbolic relation between the time of operation of the relay and the plug setting multiplier. I hope you are getting this, everybody. Now see. Now this is going to be a constant, time of operation of the relay for TMS1. This is the constant. TMS1 means you are not giving any time diversification, yes or no? So it is going to be a fixed value. So can I say the operating time is, actual operating time is directly proportional to the time multiplier setting? Yes. You can say like this. Suppose we have different cases of time multiplier setting. For example, this is the plug setting multiplier. This is the time of operation of the relay. This is one case. This is another case. This is another case. Okay. Now at a particular point, suppose this is the severity of the fault for which you want to do the comparison. Severity of the fault is fixed. Now listen, suppose this is time multiplier setting 1, this is time multiplier setting 2, and this is time multiplier setting 3. So for a given fault severity, how dangerous your fault is, this time multiplier setting is giving you T1, this is giving you T2, and this is giving you T3. Yes or no? So very easily you can say that T1 is more than T2 is more than T3. Yes or no? T1 is more than T2 is more than T3. From the time axis you can observe T1 is more than T2 more than T3, but you have seen that for a given operating time for TMS1, operating time is directly proportional to TMS. So can I say time multiplier setting 1 is greater than time multiplier setting 2 is greater than time multiplier setting 3? Yes or no? This is what the first statement says. It says that for a given plug setting multiplier, once you fix the severity of the fault, if the time multiplier setting is increased, then the relay operating time is increased. So if TMS is increased, relay operating time actually is also increasing. So statement 1 is 100% correct. Statement 1 is 100% correct. Statement 2. It says the time multiplier setting can be increased by increasing the distance between the relay contacts. This is true. but this is not the correct reasoning for statement 1. So B is going to be the correct option, where both the statements are correct, but statement 2 does not give a correct reasoning for statement 1. I hope it is clear for you. Even though they are not going to ask the exact question, but definitely similar concept is going to be asked, may be asked. Now see the next question. You have to formulate, you have to construct the Y bus here. So this is the system given. So it is a 3 cross 3 matrix it is going to be, because there are 3 buses, bus number 1, bus number 2, bus number 3, but be very cautious, because it says that the diagram shows the per unit impedance of each element, per unit impedance of each element. So the first thing you have to do is you have to transform them into their equivalent Y. Yes or no? Yes. So what is 1 upon J 0.1? It is going to be minus J10. What is 1 upon J 0.2? It is minus J5. Yes or no? Yes, option B, Raghu, option B. What is this minus of J 0.08? Because it is a capacitor, that is why its inductance, reactance is, capacitive reactance is negative. So this is going to be 1 upon J minus J 0.08. So just find it. It is going to be 1 upon 0.08. So it is going to be 4. This is 50. This is 2. This is 25. So this is 12.5. Okay. So it becomes J 12.5, because 1 upon minus J will become simply J if you take the inverse. Yes, Nitin. Wait. So this becomes again minus J10. Now very easily, first you cross check the diagonal elements. What is going to be Y11? All the branch admittances directly connected to bus number 1. So minus J1 minus J10, so it is minus J15. Minus J15. Y22. Y22 minus J5 plus J12.5. So 12 में से 5 चले गए 7. So it is J7.5. So J7.5. Y33. It is 12.5 minus J10. So it is J2.5. It is J2.5. First you cross check the diagonal values. I think only the C option is going to match. So no need to examine it further once you get it. From the diagonal elements only you can find. Okay. Now let me tell you one thing very frankly. Some of you might be thinking, why sir is taking very easy questions. Yes or no? Are you, tell me honestly, you are getting this feeling or not? Yes? Now see, it's my point of view that once you are very close to the examination, you should always focus on your strength. If I give you a very tricky question for next 5-10 minutes, your mind is boggling. Please understand, only 10 to 15% of the questions are going to be like that kind of mind boggling in the real gate examination. Are you getting that? Rest 70% of the questions are going to be easy questions. Gate examination is not introduced to give problems in your life. It's simply to test your potential and not just the intelligence or knowledge. It's about time management, how smart you are, how smartly you use the resources you have. Are you getting this or not? So that is the reason. It may look like simple to you, but at the same time, it's just the concept. Even if you are getting a tricky question in the gate examination, these are the concepts you have to use. Okay. Anyways, see the next question. At an industrial substation with a 4 megawatt load, now the real load connected is 4 megawatt A capacitor of 2.5 MVAR is installed to maintain the load power factor to 0.97 lagging. So, the reactive power supplied by the shunt capacitor is 2.5 MVAR. And the power factor maintained in the first case is 0.97, and that is lagging. If the capacitor goes out of the surface, now this becomes the second case. This becomes the second case. Generally, we are talking about the second case as the first case without shunt capacitor and with shunt capacitor at the second case. So, don't confuse with that. Are you getting this? So, cos phi 2 is going to be, okay, you have to find what is the load power factor when the capacitor goes out of the service. Now, please understand this. Suppose the reactive power supplied by the shunt capacitor is this. Okay. How much reactive power shunt capacitor is supplying? Can you tell me? How much power shunt capacitor is supplying? Can you find it? Yes. Just find the difference when the capacitor was not in service. When the capacitor was not in service, see this. The situation is like this. This is the load connected, and this is the shunt capacitor. Yes or no? Now, suppose initially shunt capacitor was present. Listen very carefully. Initially shunt capacitor was present. So, from here power is coming as Q1. Power supplied here is Q shunt capacitor. Yes or no? Hello? Yes? And this is Q load. I am only talking about reactive power right now. So, can you say Q1 coming from the supply side plus the reactive power supplied by the shunt capacitor is going to the load? Yes. Now, this is case 1. But if the capacitor goes out of the service, it means it is not available. It means the total responsibility of supplying this real or reactive power to the load lies with the generator. So, in the second case, if Q2 is the power supplied by the source to the load, then this is going to be equal to Q load. Hello? Are you able to follow this or not? So, can I write Q shunt capacitor as Q load as Q2? So, can I write Q2 minus Q1? Yes or no? Have you listened that song, Aa Gaya Q2? Okay, before you go to sleep, listen it. You will feel relaxed. So, what is Q shunt capacitor? It is Q2 minus Q1. How you write Q? How you write Q? This is P, this is Q, this is phi, this is S. So, Q becomes P10 phi. So, can I write Q2 as P load 10 phi 2 minus P load, because real power transaction is not happening with the shunt capacitor, it is same. So, P load multiplied by 10 phi 1. Now, P load is same in both the cases because adding the shunt capacitor does not have any real power exchange. So, you can write P load as 10 phi 2 minus 10 phi 1. Now, sir, what is Q shunt capacitor? It is given. It is 2.5 MVAR. So, 2.5 MVAR divided by P load. Divided by P load is 4 megawatt. 4 megawatt. So, Q shunt capacitor divided by P load plus 10 phi 1. Yes or no? Plus 10 phi 1. Plus 10 phi 1. Plus 10 phi 1 is equal to 10 phi 2. So, just calculate it. Just calculate it. What is 10 phi 1? 10 phi 1 is going to be 10 of cos inverse 0.97. Just tell me the value of 10 phi 2. Once you calculate tan phi 2, you can calculate phi 2. From here, you can calculate cos phi 2. Everybody is getting the idea, yes or no? Yes? Is it clear, everybody? So, anybody is getting the answer? Everybody is getting C as the answer. I think you must be getting B. Somebody is getting phi 2. Raghu is getting 41.2. Others, please confirm this. 41.2. 41.2 degrees. So, now you are getting 0.75. Perfect. So, it becomes 0.75 and that too as lag. So, B is the correct option. Is it clear, everybody? Somebody was getting 0.8. Please correct it. See the next question. Question number 9. A three-phase induction motor of 500 horsepower has 90% efficiency at 0.8 power factor lagging. A loaded 120 kilowatt synchronous motor is connected so that overall power factor becomes unity. Find the power factor of the synchronous motor. Similar to this question we have done, but let us do it. So, the situation is, this is the load connected and this is the synchronous motor. So, this synchronous motor is nothing but a synchronous phase modifier. It is having some real load connected to its shaft. This is a different load, this is a different load. It's a mechanical load, it's an electrical load. Now, this is the power coming from the supply. This is the load. Now, load is going to have real and reactive requirement of the load. Yes or no? Now, this is the synchronous motor. This synchronous motor is taking some real power from the system to supply this mechanical load, and at the same time, it is supplying some reactive power to the system also. The crux of the question is, he is saying that the overall power factor becomes unity. Overall power factor becomes unity means what? Suppose when you are connecting this synchronous phase modifier as a power factor improvement device, you are not at all improving the power factor of the load. Once you design the load, once the RLC fixed for the load, you can no more change its power factor. Yes or no? The only thing you can do is you can improve the power factor of the system in terms of the current drawn from the supply side. So, when it says power factor becomes unity, it becomes phi becomes 0. What is phi? If this is P, this is Q, this is S, this is phi. Phi becomes 0 when Q becomes 0. Now, which Q becomes 0? The Q which is coming from the supply becomes 0. It means whatever is the reactive power requirement of the load, that has to be supplied by the synchronous motor only. So, can I write Q load is equal to Q synchronous motor? Yes. What is P synchronous motor? It is given 120. It is kilowatt or kilowatt. So, it is kilowatt. Now, you don't know what is this P load and Q load. Yes or no? You know that? No. Because this is an induction motor. He is saying the three-phase induction motor of 500 horsepower. Now, 500 horsepower means this is the output power of the motor at the shaft. But this P and Q is the real and reactive power taken from the supply. That is why he is giving you output power and the efficiency of the synchronous motor. And he is also giving you the power factor so that you can find Q also. So, very easily for the induction motor, you can write the efficiency of induction motor, you can write P output upon P input. Now, P input becomes P load for the induction motor. Now, what is P output? It is 500 multiplied by 746. What is the efficiency? It is 90% efficiency. Just calculate it. You will be getting the input power, that is P load. Now, what is Q load? It is P load tan phi induction motor. where phi m is cos inverse 0.8. Already it is given in the question. It is 0.8 power factor. Okay. So you can calculate Q load also. This you must be getting somewhere around 300.83 kVAR. Just cross check this if it is correct. And this you must be getting, I think, 454 point something. Just calculate if you are getting. P input you should not be getting 41. Something wrong you are doing. Please cross check it. Everybody is getting 41.44. I don't have a reference. I'm just telling you. I don't know. Please cross check it. Please cross check these values. I don't remember the reference values. Everybody is getting P input as 41.44. Please cross check these values. Because whatever you are getting as Q load, that will become Q synchronous motor. And once you know P and Q of the synchronous motor, you can get P synchronous motor is square plus Q synchronous motor is square. This is phi synchronous motor. And they are asking the power factor of the synchronous motor. That is going to be P synchronous motor upon under root P synchronous motor is square plus Q synchronous motor is square. Okay, it is 414.44. Okay, please cross check, Raghu, please, your calculation. 414.44. Kilowatts or watts? You must be getting it kilowatt, no? Okay. Then Q load, what you are getting? I think you must be getting 310.83. So from here you can write your Q synchronous motor should also be 310.83 kVAR. So you can calculate, you must be getting it somewhere around 0.36. Now it is leading or lagging, you can cross check. I have already given you in one of the session, I have given you the trick how to find the operating power factor, whether it is leading or lagging for the synchronous generator and synchronous motor. Okay. Now please understand, this synchronous motor is supplying this much reactive power to the system, and this is the lagging reactive power. Synchronous motor is overexcited. That is why it is supplying reactive power to the system. But which reactive power it is supplying to the system? It is supplying lagging reactive power. But what is the basic nature of a motor? The basic nature of motor is not to supply power but to absorb power. So if it is supplying lagging reactive power, it means it is absorbing leading reactive power. So what is the operating power factor of the synchronous motor? It is leading. Is it clear, everybody? See the next question. For a given network, choose the correct statement. Very interesting question. On the basis of real and reactive power flow, the four statements given, there are bus number 1 and bus number 2. It is JX, so it is a lossless. When it is lossless, you can say X by R ratio is extremely high. When X by R ratio is extremely high, you can be well confident, 100% confident about the direction of real power flow. The real power flows from leading voltage terminal to the lagging voltage terminal. So this is leading plus 30, this is lagging 0 degree. So 1 to 2 real power flow. Real power flow from bus number 1 to 2. So statement 1 is 100% correct. When it comes for the reactive power flow, you have to cross check with both the cases. With both the buses you have to cross check, because in reactive power you don't know what is happening, all the three cases possible. So for case 1, you are assuming that reactive power is flowing from bus number 1 to bus number 2. It means, listen very carefully, if reactive power is going from bus number 1 to 2, then mod V1 cos del, where del is the relative phase angle between V1 and V2, should be greater than mod V2. Yes or no? This should be the case. I'm just writing it here for your reference. Don't confuse. So you can write it the condition if reactive power is flowing from 1 to 2, mod V1 cos 30 cos del is greater than mod V2. What is mod V1? 1. What is cos del? Cos 30 degree. This should be greater than 1. This is not possible. Cos 30 can never be greater than 1 because sine or cos values are always less than or equal to 1. So, opposite to the assumption, as per the conclusion, reactive power is flowing from 2 to 1. Now you have to go to the other side and cross check. If you take the second case and you assume that no sir, reactive power is flowing from bus number 2 to bus number 1, then you have to write, listen very carefully, mod V2 cos of minus del, because it is the relative phase angle where you are standing. When you are saying sir, reactive power flowing from 1 to 2, it means you are standing here. When you are saying sir, reactive power flowing from 2 to 1, then you are standing here. So where you are standing, with respect to that, you find the relative phase angle. This should be greater than the magnitude of V1. Again, magnitude of V2 is 1. Cos minus 30 is cos 30, so it becomes cos 30. It should be greater than 1. Again, it is not possible. So again, it is opposite the assumption and it says reactive power is flowing from 1 to 2. Now, when the reactive power is flowing from 1 to 2 and 2 to 1, you can very easily understand the situation is like this. So where this reactive power is going, this reactive power is being absorbed by the transmission line. Very interesting case. So whenever you have to find the direction of reactive power flow, always cross check it from both the sides, then you give a judgment. So reactive power flows from 1 to 2, correct. 2 to 1, correct. Real power 2 to 1, wrong. So 1, 2, 3, A is the correct option. Is it clear, everybody? See the next question. A 110 kilovolt 50 hertz 3-phase 200 kilometer long transmission line has the following ABCD parameters. If the no load receiving end voltage is given, then the open circuit power loss in the line will be. Now, it is a long transmission line. Now you understand, for a long transmission line or any transmission line, you can write Vs is equal to AVR plus VIR. Is is CVR plus DIR. Now IR is 0 because it is no load. So can you tell me what is Vs? Yes. What is A? 0.979. Angle is 0.618. 0.618. This is A value. What is receiving end voltage? It is 110 kilovolt, but it is the line RMS value and you have to change it to the per phase value, because ABCD parameter calculation you always do in terms of per phase. So 3 phase you have to divide it by √3. So it becomes 110 kilovolts divided by √3 and take it as a reference. Receiving end voltage. Just find what is the value of Vs, and this Vs you are finding as phase. Yes or no? Similarly, can you find Is, the sending end current? This is also per phase. So C value. What is C value? 0.528. 0.528 10 to the power minus 3 angle 90 degree. What is the receiving end voltage? Again, 110 kilovolt divided by under root 3 angle 0 degree. So you got the Vs also, you got the Is also, and you will get the phase angle also. You will get the phase angle between the Vs and Is. Okay, I don't have a reference, you have to solve it. See, I can answer your question. Okay, I can answer your question. One thing is, before you go to the exam, okay, just some random calculations you can check. For example, you have 2-3 complex quantities, how to add them effectively. This is your brain mapping, how effectively you can map your brain. Okay. But suppose in the real examination, you are stick with the calculation. Maybe it may happen with anybody. So please understand, don't take any further pressure on your mind. Whatever you have done in the scribble pad, the rough sheet, just keep it there and always do the calculations very neatly. Don't do it like this. Otherwise, if you have to review it, you will not be able to review it and you have to repeat it. So because you have enough time. Okay. GATE exam is not about speed. It's on little bit balanced speed is required. It's not that one question you are doing for half an hour. No. But almost you are getting 3 minutes for a question. It means sufficient time you have for the question, because most of the questions you will not need more than 1 minute or 2 minutes. So whenever you are stuck with the calculation or any other thing in the examination, control your emotions, leave the question then and there, and just believe in yourself and go for the next question. Okay? Because you're not going to solve those questions in the examination which others cannot solve. You have to first solve those questions in the examination what average other candidate is going to solve. That is your first choice, because it's relative. Once you are done with those average number of questions which others are also solving, then you will go for Excel. Is it clear? So once you get this, you can find the no load power. Okay, no load power, this is going to be 3 times V phase I phase. This is going to be cos phi S. This is sending in, because per phase voltage and current you have found, so you can use this. So this is all from my side, friends. Thank you so much for joining me live in the discussion. I hope you enjoyed the session. But before I leave, if you have any more doubt, you can ask me. But let me just inform you about the GATE and Engineering Services test series on BYJU'S exam prep, which gives you unlimited access to the full-length mock subject-wise test. The link is given in the description that you can follow. The main features of the test series is 60 plus tests covering GATE and ESE, detailed mock analysis, virtual scientific calculator, 4000 plus practice questions, all India open mocks created by GATE experts. So everybody just hit the like button, bell icon, and subscribe to BYJU'S exam prep if you have not subscribed. Thank you so much. Thank you so much. Take care. PDF I will be uploading. For 111 top questions, I will be uploading. And the Telegram channel of other faculties like Rakesh, Thalreja sir, Ankit sir, and DB sir also, you will be getting the PDF. Don't worry about the PDF. Tonight itself it is going to be posted, I hope. Is it clear, everybody? So once again, thank you so much. Best wishes. Stay happy, stay connected. Subscribe to BYJU'S exam prep. Thank you so much. Thank you, everybody.